You ready to get started? What are we doing today? Going over the homework you just handed in, then we're going to talk about chapter 15. We already did EOQ last week, right? So we have 3 more. There's 4 inventory models you're learning in this class. And here are the other 3 that we hopefully will get through today. And then, let's see, what about Thursday, chapter 1. Next week, we hopefully finish chapter 1, and you got a quiz. So you got a quiz in 9 days. Does that sound right?
What?
9 days? Does that sound right?
Yes, sure.
Okay. And it's over 3 chapters, 13, 10, and 1, right? That however far we get? All right, let's do this. And this, by the way, oh yeah, this homework assignment, 1, 2, 3 problems will be posted tonight, and it's due on Wednesday. All right? So if we have time at the end, I'll bring that up again. Here's chapter 10. This is where we edit back in. Chapter 10.
Wait, you mean Thursday?
What did I say?
You said Wednesday.
Thursday. Thank you. Man, nobody heard a word I said since I said Wednesday. You guys are all stuck on that. It reminds me of something that happened. 4 models. We covered the EOQ. When is EOQ used? It's when somebody's buying goods from a supplier. They have to order it from somewhere, somehow, and there's a lead time for it to come. And then they use that. It could be raw materials. It could be things that we sell. But they're ordering it from somewhere. That's kind of what EOQ is. The next one, production lot size. The story's all about they're making something, manufacturing something. And this is all about how many they should manufacture before they stop to make something else. Inventory model plan shortages. The story's all about we're thinking about running out on purpose. Okay, so you tell the difference. I'm telling you, with chapter 10 questions, if you can spend as little time as possible trying to figure out which one you just read, that's what takes up the time. That's why time will be your worst enemy on the quizzes. They're time quizzes. And the challenge is that you need to make yourself familiar enough with each of these that you can read a column and go, okay, that's inventory, that's chapter 10, and which inventory model did you just read? So here's the hints you put next to the name of each one that I'm trying to give you here. This is if the story is about something being manufactured. That's production lot size. This inventory model with plan shortages, the story is always talking about running out on purpose, or running short to see what happens. Would we save money? And companies, by the way, would only do this if they knew they weren't going to lose the sale. That they had high confidence that this thing's so unique that if we don't have it for a day or 2, that person will come back and still buy it. That's plant shortages, and a lot of places will do that. Airlines, they purposely do plant shortages. We'll get to that in simulation work. Quantity discounts, this is very common. And this is used when the story's about you can get a discount if you increase your order. As a manager, you're ordering from somebody and they're offering you a discount to increase your order. Instead of ordering 500, hey, increase it to 1,000, we'll give you a 7% discount on the whole order. That is a story that you would use quantity discounts formula. So there's 4 formulas. Recognizing which one to use. Then identify the variables and plug the numbers in. That's it. That's how you do these. No memorizing. Just understanding, looking at examples and apply, refresh your memory by seeing the example and then apply it. Let's get to it. Here's the one with the parameters. We're ordering from a supplier. That's why we're using this one. The key information you need here is the optimal quantity formula to order the optimal quantity, your total cost formula. Again, go back. Right here, this total cost formula. Now remember, total cost formulas are different for each one of these, even though they kind of look alike. There's differences. So total cost formula you need to know. And another real important one for this one is the reorder point. Where is it? Anytime. Reorder point right here. Is this it? It's how many the company would go through usually in the amount of time it takes to get one in. To get an order in. Excuse me. So there's lead time. Those are the 3 main things you should focus on this one. The other items are going to be covered more in operations. You're going to go more in depth in each of these. Okay, The next one is the production lot size. The production lot size, you definitely want to highlight the optimal production lot size, the quantity that should be made in what's called a run before you shut the machine down to do something else. The total annual cost, of course, look at the formula is similar, but notice it's using demand over production capacity here as an example of a change. And then number of setups. We're there. Number of runs per year, or number of setups, annual demand divided by the optimal quantity that you would do in a run. Those are the three main formulas I want you to focus on for that one. And here's our example. This is where we left off. Here's our examples. Here's a company. It makes tiles. They have this machine that's making individual tiles. And right now, that machine's running to make 100,000. They stop the machine, they use it to make something else, they come back, set it up, makes another 100,000 tiles. And they do it again. Shut it down, retool it, make something else, shut it down, retool it, make more tiles. Another 100,000. 10 times a year, they're doing this process. And they're making 100,000. And the reason they're doing 100,000, the reason they're doing this 10 times is because they need 1 million per year. They sell to their customers, who are retailers maybe, or wholesalers, 1 million a year of this one time. Okay, so what variable in the optimal quantity do you think this represents? I couldn't hear you.
Demand.
Demand, which is D. Demand. Annual demand, no converting either. 1 million. Now, the setup cost, $5,000. You know, maybe this is oven, you know, maybe it's baked, because maybe it's made of ceramic and it has to be baked, and there's all kinds of retooling going on. So it's a very expensive setup cost, $5,000. Again, this is replacing that C sub O, which was an ordering cost in the other example. And this one is setup cost. It's still in the formula as C sub O though, okay? And then holding cost is 10% of the manufacturing cost of one tile, and it costs us, the company, $1 to make a tile. That's what we have into it. Materials, labor, whatever it may be, $1. Holding cost 10%. You tell me how much holding cost is per tile.
10 cents.
10% of $1, 10 cents. In that formula, C sub H would be the 10 cents there. 10% of the cost of one tile. Don't get shocked if it's given to you as 10 cents. You don't have to do any multiplication times the cost of a tile then to get your holding cost. It's given right to you, 10 cents. Could be either way, so I'm waking you up to how to expect it. If we were to keep that machine on, making tiles the whole time we're open, making things, and not shut it down, that machine would make 500,000 per month. That's the capacity. But what do we have to do to that for the formula? 500,000 per month if we kept the machine going. That's right. You got to multiply it times 12 to get the annual capacity. So 500,000 times 12. Your annual demand, $1 million. Annual capacity, whatever this is, which is 6 million. All right. 12 times 5 is that 60? Yeah, 6 million. So you'd have 1 million over 6 million in that formula for that part. And don't forget, order of operations, divide 1 million by 6 million before you subtract it from 1. And I'm talking about right here. 1 million divided by 6 million before you subtract from 1. This is always going to be a number less than 1 in these parentheses. And if you got 1 point something, you accidentally subtracted this from this before you divide it. And that's why you're getting such a weird number. This is a very common mistake, so that's why I'm really pointing this one out that I see every semester. The factory is open 365 days a year. Go ahead.
So does P stand for the production capacity?
Exactly.
Okay.
Which is the 500,000 times 12 months. So here we go. We went ahead and said demand's 1 million. We converted production from 500,000 a month to 6 million a year. We multiplied 10% of $1 to get our holding cost of 10 cents. And our setup cost was given to us as $5,000. We plug it into, where's our formula? We took our total cost formula and we went ahead and used algebra. We plugged everything in we know. Tell me what's plugged in right there, that C sub O, what number would be right there? Making sure, there you go, 5,000, the setup cost. What about right here? What would you plug in right there? 10 cents, we're with it. Good, we got it. Just plug it in. I don't use algebra to break it down to this. I wait until I know what Q is when we calculate it, then plug it in and do that. Now, here it is. How many should that machine be making instead of shutting off after 100,000? Demand, 1 million a year. Ordering cost, which is setup cost on this one, 5,000. D over P, 1 million over 6 million, which would be 0.16? 1 divided by 6, 0.2? Anybody?
16.
What is it? 1 divided by
16.
0.16. It is 0.16. Is that right? Anybody?
Yes, 0.16.
Okay, so now what's the opposite of 0.16? 0.84, right? So this right here, this turns into 0.84 times the 10 cents. Million times 2, 2's in stone. It's there in every one of these equations. Do not get rid of that 2, it never changes. It's given, it's just understood like E or pi. Million, 5,000, 1 million over 6 million, just eliminate the zeros to make it easy, that's all. You can eliminate all 5 zeros on each one of these.
Where'd that like holding cost go?
The holding cost, where does it go?
Yeah, see how it's up there?
Yeah, it's just on the other side. That 10 cents should be right there.
Oh, okay.
That 10, it's 10% of a dollar, so 10 cents.
Okay.
It's just been moved to the left side instead of the right side. But you got to make sure and subtract this before you multiply for sure.
Alright.
In that parentheses. This company should not stop at 100,000. That machine should keep going until they get to 346,410 and then stop. And so what's happening is there's two parts of this total cost up here. There's the setup cost and the holding cost. And when I want you to think about this logically. There's the holding cost and the setup cost. They're running that machine and stopping too many times. So it's causing one of these two costs to be much higher than the other, which is causing the big picture to be wasting money. Think about it for a second. If they're running it too short of a time and having to, do this 10 times instead of letting it run longer, which cost is too high? Not the holding. Yeah, 50-50 chance. Yeah. Here's the reason why. You've got to think about it this way. If they're not running it long enough, that means they're setting it up 10 times. So many times that $5,000 is eating up the profit. And that cost of $5,000 is so high that they shouldn't be setting it up 10 times. They have warehouse, and they should increase the holding cost and let it run longer so they don't have to set it up. The holding cost is so far less expensive than the setup cost that they need to let it run longer and let it sit around because of that 5,000 setup cost. It's eating up the profit. It's when these are in balance that the company's running smooth and not wasting money and able to give Christmas bonuses and big raises and all of that stuff. Because right now that's money being thrown away by bad decisions. So here's the deal with this one. I think in your homework, I'm asking you to calculate total cost the way they do it now, and then the way you recommend. For example, before we get to the answer here, here's the total cost formula. We have everything in there. All we need here is Q to finish this off. You put in how many they let that machine run now, which is 100,000, and you calculate total cost. Then you plug in how many you're recommending they should make before they turn it off, which is what, 346,000 or something like that. Plug that in and get total cost. And you show them the two numbers. Hey, look, this is what I used to do. I used to sit there and go, okay, here's an area where I found you're losing a lot of money. Look at the total cost for making this one tile. Now look at the total cost if you change the way you make this one tile. And the light bulb turns on, just like every one of these. And they go, wow, I'm wasting that much money? I mean, it looks like you're only wasting a little bit every month, but over a whole year, here's how much you're wasting. And then, how many different items are you making in your shop here, in your company? And you could be losing that much every year on every one of those items if that's how it's done. Now I want to jump to, I may have already told you this, but in my experience, whenever I walk up to somebody and say, why are you making 100,000 of those? The answer is almost always, not always, but almost always, this is how I was trained to do it. This is how the person before me did it. And so they just keep passing on. Every time they have someone will have that job for 3 to 5 years, and they pass on the bad decision to the next person, and they'll constantly lose that money. 346, 410 is how many they should do instead of 100,000. Here's a number of runs. Right now, they're setting it up 10 times. 1 million divided by 100,000, 10 times. Now it's 1 million divided by 346,410. Less than 3 times a year. Instead of spending $5,000 10 times, you only have to spend $5,000 1 year 3 times, another year 2 times. It's a little more than a year, a little less than 3 times. That setup cost comes way down over a year, but the holding cost goes way up. But the holding cost is so less expensive in the big picture compared to the setup cost that if you can get up to break even where they balance out, now you're not wasting money. If you make too many, and someone always said, what if I make 500,000? Why 346? Now your holding cost is getting out of control, and your setup cost did come down. But your holding cost is so out of whack, you're wasting more money. It's having the two in balance. Here we go. Currently, making 100,000, you're spending $54,167 a year on setup and holding costs. If you switch to 346,000, you bring that 54,000 down to 28,868. Now I love this one. That is an extreme difference on one item. That's unbelievable. Look at the additional profit by changing the way they do something. The next step now is to write the procedure up in writing so that from now on, if anybody's going to switch positions or someone leaves, you have to retrain somebody, you have something in writing of the right way to train them and how many should be made instead of the wrong way. And in that manual, I always, I say, do you want, when I was at a company, I'd say, okay, the next step is, I got to fly out and I got to go analyze it in the company. But you can either make these changes yourself, get this drawn up, write in there how it's calculated, so somebody who gets trained on this job can recalculate the optimal amount they should be making. And get it all in writing so your company can direct itself without you having to constantly watch this person and make sure they're making the right amount. Or you can have somebody from our company come in and write this all up for you. And about 50% of the time, a little over, they would rather pay, have somebody flying from our company to write all these manuals up for them for all these changes. They were looking at $20,000 to $30,000. The 2 people that would fly in just write all these manuals may only be there for a whole week. They're working their butts off for the whole week, putting all this together for you, so you have now all the tools necessary to not waste money from this point on. But if they have the cash, instead of them doing it themselves, they would better pay $25,000 to have someone else come in and do it. And I've already flown out to the next company by that time. Everybody see this? This is so important. If a company that you go to, you interview, you get hired, and they're not doing something like this, boy, oh boy. This is all I'm asking is for half of this in a raise, next raise. This is kind of words you're saying. Look at what I'm doing this for you, and I want to show you how much money you can save because you're at this company, and then you jokingly say, and all I'm asking is half of that difference in the next raise. Okay. All right. Again, number of runs, optimal quantity to produce, and total cost. Okay? Next, planned shortages. I want to emphasize that a company doesn't go into planned shortages unless there's a good reason, because it can increase profit, for sure. But you got to realize how much goodwill cost is going to be involved if you pick a product that you're doing in your business to short. Because when you short something and somebody has to wait for it or they have to go somewhere else to get it, there's a cost. You don't see it directly, it just happens. Almost like an opportunity cost. Because maybe they're not coming back or something. So when a company's looking at this, they hopefully are only considering it on any items that are so unique that they don't have a lot of competition for it. You gotta remember, back in my day, the internet was not available. So there was a lot of items a lot of companies had where they didn't have competition because somebody couldn't just get on the internet and find it 60 miles away, order it, and have it delivered. That didn't exist. So most of their customers that did this were items they knew that another customer, the amount of work it would take them to find it that it's 60 miles away, and then to get it and get it in, they wouldn't do it. So they're gonna come back and get it from us. And they realized by shorting it on purpose, and maybe having to go a day or two without it, increases profits. Because a lot of companies will embrace this. When you have a question like this, or if this is in real life, you calculate the optimal numbers as if there's no shortages, then you recalculate whatever numbers, total cost especially, again, if you implement a shortage policy, and see exactly how much money would be saved on that one item. So, in this case, oh yeah, the variables. Let me get the formula. Formula is similar. Matter of fact, this is EOQ right here. But with shortages, you have to multiply the EOQ part to the shortage part, which is the square root of, you ready? The holding cost plus a brand new variable you haven't seen yet. C sub B stands for back order cost, always given to you in this class. You add the holding cost and back order cost first, then divide by the back order cost, then square root it, then multiply.
What is C sub B again?
C sub B is the back order cost. There's the new variable that you haven't seen yet. And it will be given to you. In real life, there's some work involved. You got to say, okay, let's pretend we lost the customer. You know, are they coming back ever? How much was the profit on that? Opportunity loss, blah, blah, blah. A lot involved. Now, this is an additional item. This is the maximum amount for that item you would ever want to put on back order, the amount of back order. So, boy, I want to make sure you get this, you guys. For example, you're managing an inventory, and you set this item's reorder point to 14. The computer's watching inventory, because every time an item goes out the door, it takes it down an inventory count on the computer. And the computer's watching. And as soon as inventory gets to 16, or 14, excuse me, it realizes, okay, we're at the reorder point. The computer then notifies the person who orders that we need this item. We're at that point. That person knows they got to order it by the end of the day in order to make sure that we get the new items in right at the time we're running out. This reorder point of 14 was calculated based on the time it takes to get a new order in from when we place the order. And this is the spot, the just-in-time inventory reorder point. Now, if you're going on back order, and you want to have one item on back order, and you're a manager, and you do all this, and you say, you know, I'm going to try back order, it looks like we could come out ahead. All you got to do is lower your reorder point by one item. And what happens is, the computer is watching the inventory, and it's comparing it to the reorder point for every item. And this item comes along, and it got to 14. No notice. It is not going to let anybody know that we're at 14 now because the reorder point got switched to 13. Now when it gets to 13, it's going to send the notice. Now here's what the deal is. There's some time that went by waiting to go to 13. And that time that went by is eating up into the reorder delivery time. Lead time. Thank you. Nobody. Lead time. It's eating up into the lead time, which means now I'm placing my order maybe a day late, maybe a couple hours late, whatever lowering of one would be. And because I'm ordering late, I'm going to run out maybe a day before that truck gets here. That's what a back order does. This S is the maximum you would ever move your reorder point down. That's what that S means. If this comes out to 3, and your reorder point normally is 14 for just-in-time inventory, the most you want to take that down is 3 items. Or you just are now eating up to the money you would have saved if you go more. You get it? Okay. So there's the optimal quantity that you would order. This is the reorder point, or I'm sorry, the maximum amount you would adjust your reorder point, which is the amount you would have on back order. And then your total cost. Look down, there's 3 parts. You're holding, you're ordering, and now you have a little part here, your back order cost. And we'll let the problem speak for itself. You ready? You have a rental car business. And you're in LA, I think. Yes, LA. And your Hervis rental car business, you know, you're getting sued because you stole part of the name, but still, your Hervis, all right? And you got 2,500, all the same cars. You bought 2,500 over the years that you're renting out. And they're called Rockets. You happen to have a central garage because of all these cars, there's always some that need to be repaired. The most common repair is engine replacement because of how many miles are being put on so fast. The cars are still in great shape, but you're just replacing the engine and getting it back out there to rent again. A lot less expensive than buying another car. On average, 8 of these cars per month are requiring a new engine. So you're running the central garage, you're going, okay, I'm going through 8 engines a month, and you say each engine happens to be $850, and every time I have to place an order for new engines with the supplier, everything that's involved in putting the order together it ends up eating up about $120, mostly in time. And where's the holding cost? Blah, 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 blah. Hang on. And the annual holding cost is 30%. What do we, here you go. You ready? What do we multiply 30% by? Give me the number. 30% times, wait a minute, we're recording, right? I just want to make sure, this, you know, this is participation time. The holding cost is 30% times what? 850, the cost of one engine. There it is, 850. That's how you get your holding cost. Remember, it's the cost of one item, whatever it is that we're talking about. You were completely blank on the answer to that question. You've got to get yourself ready. So 30%, and every time we place order for engines, it takes 2 weeks to get the delivery. This is called your lead time, 2 weeks. So we're going to figure out our reorder point based on 2 weeks, and then we'll figure out what our reorder point should be adjusted to. If a car's out of service and we don't have engines to put in it, we're losing how much money? $40 a week. Each week the car's out of service, we're losing $40 a week. Here's my hint. Because demand is going to be on an annual basis on that formula, you're going to take your back order, however it's given to you, and make it annual back order. For one item though. So if we're losing $40 a week if a car's out of service, how much would the back order cost be in total then for a year? Or what would you multiply it by? 52 weeks a year. And it says it's open all year, right? Let me go back. Is it open all year? If there's ever a problem that doesn't tell you that how long they're open, you must assume the whole year. Just make that assumption. On quizzes, I almost always tell you how long. Unless I forget. You ready? So here we go. EOQ, same as always, 2 times the annual demand. Wow, we got to talk about this. We're going through 8 engines a month, right? There's 8 of them that need engines replaced on average a month, 12 months a year. We're going through 96 engines a year. There's our annual demand on engines. Next, whole ordering cost is set at $120 every time we place an order. Next, our holding cost, 30% of $850, which is $255. There's the left side. 96 times 120 times 2 divided by 255. The right side, our holding cost is $255. We already calculated it. Back order cost, $40 a week, 52 weeks a year, $2,080. So our 255 plus the 2,080 divided by, add this first. That's why it's in parentheses. Then divide, then square root. Now take your 2 square roots and multiply them. We should be ordering 10.07 engines every time we place an order. All right? How many is the most we would put on order? Real quick, before we go on to that, let's go to the reorder point. Reorder point, how long does it take to get an order once we place it?
2 weeks.
2 weeks. Okay? How many engines do we go through in any amount of time you want to tell me? How many engines do we, on the average, go through in a blank time? 8 per?
8 for 2 weeks, I thought.
No, I think it's 8 per month. Let me check this.
So that was like.
I had 3 different answers there.
4?
We're 8 rockets per month.
Okay.
Okay, 8 per month.
So it's.
Now, hang on. Who? No, Chase, you're jumping in this. You ready?
So
Here's the deal. We have to convert what we know into what we don't know to find the reorder point. And the reorder points always. And I hope you got this because you definitely got at least 1 or 2 reorder point questions coming up in your future. The reorder points always equal to how many the company goes through in the lead time. 8 per month is the same as 8 per how many weeks?
8 per 4 weeks.
That's right. So 2 weeks lead time means we'll go through how many in 2 weeks? 4 per 2 weeks. You got it. We're setting our reorder point at 4. Okay. Now, we're going, well, what should we lower the 4 down to in order to have back order? Because right now, when we get down to 4, we're putting an order in, and it takes 2 weeks for them to get here. During the 2 weeks we're waiting for the order to arrive, we're putting new engines in cars. As a matter of fact, we're putting in 4 engines during that 2-week period waiting for the order. We're finishing up the 4th engine into the 4th car, and look at that. The truck just arrived with 10 or however many engines we ordered. That's called just in time. Matter of fact, some of the employers are getting them off the truck right now as we're checking and testing this engine out. That's how just in time we are.
So if you had like 9, you use 9 per month, which and it'd be
How
like-
much time, how long will we be without an engine that we have to find something else to do? How much time do we go through one engine on average? That's kind of your question in a way.
Yeah.
Get it? How much time, how many engines do we go through in 2 weeks? 4. So we must be going through 2 engines every week. So a half a week, wait. So if so my question is, 1 engine, let me do this again, 4 in 2 weeks, 2 in 1 week, how much time goes by when we're talking about 1 engine?
3.5 days.
3.5 days, half a week. Half a week. So, what you just calculated, which I think his question was, how much time will we be without engines, waiting for that order to arrive, and not being able to work on cars, I think, right? And so, in that case, it's a half a week. There's 3.5 days that we, or if we're open 7 days a week, there's a half a week that we can't work on a car doing engines. But the good news is, if that's the case, we have a half a week now to catch up on all the other things that need to be done that are having nothing to do with replacing engines, which isn't so bad. But it does mean that there'll always be a car not out there that we could have had out there because we can't finish it because the engines didn't arrive. You get it? And that's where the back order cost comes in, because it's not out there earning us money.
I thought that you got charged $120 per order, not per engine.
No, per order.
Okay.
Per order. That is per order,
Okay.
not per engine. And that's why it's being multiplied times total demand, times
Okay.
2, then divided by the holding.
Yep.
Okay. Are you ready? So we have the applicable quantity 10. We're plugging in the holding cost 255, the back order cost of 280 here. Add these first, then divide to that, multiply times 10. 1.09 is the most you should have on back order, because if you go more than that, if you calculate total cost using 2 or 3 compared to 1, you'll see that the total cost becomes more expensive. That the exact spot on the dip, that if you're going to have a back order, this is the most you should put on back order in order to save money, if you're going to have it at all. So now, and because we're taking into consideration how much money we're going to lose, it's telling us we would save money by putting at least 1 on back orders. We could take this 4, switch the reorder point to 3. 1 represents a half a week, usually is how much time it takes to go through. So at the end, we placed an order. It takes 2 weeks to get the order in. We're putting engines in cars. 1 week goes by, a half a week goes by. We got a half a week left before those engines arrive. We're finishing up that car, and we have no engines with a half a week before they'll get here. If it's costing us $40 a week, $2,080 a year, but let's get all this other stuff worked on right now while we're waiting for engines. Let's see if this works out for us or not. Let's get to total cost. blah, 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 where is it? Do not tell me. I don't know. I guess I forgot total cost in here, but let's talk about how we calculate it. Holding cost, I think was at 255, is that right? Optimal quantity, 10. The maximum back order is 1. Does that sound right? That star just means optimal, maximum, and optimal. It's all those stars. It's not to the power of, or it's not multiplied. Subtract these two, then square it. Everybody see that? This is in your book also. Subtract these two, square it, multiply times the h, divide by 2 times the optimal quantity, so 2 times 10. Here's the ordering cost. Annual demand, which is, what was 8 times 12? 96 inches. Ordering cost, Chase, you said $120 an order, is that what it was? $120 each one. Optimal quantity, 10. Now the back order cost. The maximum back order, which is 1 in this case, squared. The top half square means squared, I had to type that in. Back order cost, was that 2,056? 2,080, thank you. Divided by 2 times 10, the optimal quantity. Do all that and you'll have your total cost. So for this one, optimal quantity, maximum back order, and total cost are the 3 things you should have prepared as to how to do those. Okay? And now I want to prepare you. If this were a customer and they said, we're thinking about doing a back order cost, now that you did all this, calculate their total cost with no back order. Which means you take whatever was calculated here and don't multiply it times that. And that's your Q, and you use the EOQ total cost formula to get their total cost, and now you compare that to whatever this total cost comes to. I want to say that again. You ready? Because I'm almost sure your homework is asking you to do this, so I want to make sure you get this. Matter of fact, let's look and see before we waste a bunch of time. See if I'm right about the homework. A manager of an inventory system has been asked to analyze the economics of a backorder policy. This is your second problem on the homework. For some products that can possibly be backordered. For a specific product with demand of 2,200 units per year, a ordering cost of $190, a holding cost of $3, and a backorder cost of $25. What's the difference in total annual cost between EOQ, which was the barometer way of doing this, which means you wouldn't even use the back order, compared to planned shortages total cost, which is the one we just demonstrated, where you would use the back order cost. Everybody see what I'm saying? So you're using the formula from EOQ, which is the first one we learned, and calculate total cost, and then do this again using the back order formula with the back order cost, and calculate total cost, and see how much money would they save if they implement this policy. Okay? It's not going to take as long as it sounds. I know it sounds like it's going to take a long time, but it won't. All right, now this next one does take a long time. Some students take this next one. Go ahead.
What is the X star symbolize again?
It's the maximum you would ever want to put on back order. The maximum you would ever want to decrease your reorder point in order to run out on purpose. Here we go. This last one. How are we doing that time? We're okay? Okay. What are you talking about? How did you forget this song? What? Oh. Yeah, that would have been a lot. Okay. EOQ quantity discount. This is very common. Very common. I faced this in my short career a long time ago, several times. If you're a manager and you're the one who has to order goods, you're going to get bugged by suppliers. They're going to bug the heck out of you. And they're going to try to get you to order more, and they're going to offer you deals as incentives to get you to order more. And you got to be careful, because as a manager, your first thought is, look how much money I saved the company, and you almost always want to order more if you feel like you're going to save the company money. Because you'll start to learn that at most companies, you get this review once a year, and your whole next year's raise is based on this review. And you want to keep track all year long of these things you've done to save the company money, And this is how you then negotiate at your review to get the biggest raise that you can. How's that? All right. So one of the ways is that you're going to be enticed once you get to a management position by these suppliers who are just kind of going, hey, let's go to lunch. Let me buy the lunch. Hey. You know, if you would just order 1,000 instead of 500, you'd get a 7% discount on the whole thing. Now let me calculate how much that is. You'd save the company $3,272 on this one order. And you're going to be tempted to say yes. And a lot of times, saying yes is the best decision. But if you don't calculate for sure that it's the best decision, you could be making a big mistake, which then could be the exact opposite result that you wanted at your annual review. It could be, look how much money we lost because of what you did in this particular situation. You don't ever want to hear that in an annual review. And this is the most likely way it could happen to you, is suppliers enticing you to try to increase your order to get that discount. Here's how you make sure you're making the best decision. I'm jumping past blah, 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 blah. You ready? You're going to calculate the optimal quantity that should be ordered for every price point. And what I mean by every price point is, a lot of suppliers will say, okay, here's the price you're paying right now, ordering between 1 and blankety blank number of items. If you increase your order to this amount and this amount, you're going to get a 7% discount on the whole order. Or if you increase your order to even a bigger amount to this amount, we're going to give you a 10% discount. So you have full price, 7% discount, 10% discount. These are the decisions you have. For example, hypothetically, you need to calculate the optimal ordering quantity from that supplier at each price point. Full price, 7% discount, 10% discount. And notice, we're calculating it here at, looks like it's a 10% discount. We're calculating it here at a 7% discount. Where's full price? Did we skip full price? Here we're calculating it at a 15% discount. I think I got my full price. Here we're calculating at full price. We're getting an EOQ, optimal quantity, at each price point. And this particular one has 4 different price points. Full price, slight discount, slightly bigger discount, and a big discount. What was it, 7, 10, and 15% off. And the EOQs are kind of close to each other. Ready? 10% off, we should be ordering about 246 items from our supplier. 7% off, about 242 from our supplier. And then the next one's going to be a little less because of the discount. Well, I mean, full price, excuse me, 233 of them. All right? So, here's the deal. Again. With optimal quantity, the EOQ that you're using is the exact same as the barometer in the first problem. But your total cost formula is where the difference comes in. And this is why a lot of people hate this particular one out of the 4, because you have to calculate your total cost at every price point. Then decide which one's the best. Should I order at full price? Should I order at 7% off? Should I order at 10% off or 15% off? Calculating total cost at each price point makes the decision so much easier, and you can't make a wrong decision this way. Allowing yourself to do the math. Now, if you end up in a position where you truly are going to be hit with decisions about whether you should increase your orders, you set this all up on a spreadsheet, and all you got to do is plug in the % discount and how many you got to order, and it will calculate and help you make a decision in seconds. You just got to plug in the information. Here's the setup, though. The annual cost is, here's our holding cost, just like the barometer, actually. Here's our ordering cost, just like the barometer, the EOQ. Here's the extra one, extra piece of the puzzle. The job is to get these two in balance at the same time, adding how much you're going to pay for the goods that you're buying, because you're going to be buying them at 3 different, in this case, 4 different prices possibly. So it's the price you're paying, the cost per one item, times your annual demand. This doesn't change. This D's the same for all 4 price points, but the price you pay is different at each price point. Matter of fact, this will keep going down. Full price, 7% off. This little part will be lower because you are getting a lower price, but you still got the same amount you gotta buy over here. A little bigger discount, a little bigger discount. It's a matter of, is the discount right here gonna outweigh the changes that are gonna take place here between holding and ordering?
So what is C again?
C is the cost that you're paying per item, which in quantity discounts will change. You gotta do it at each price item. The other thing that's gonna change at every price is right there, that H. The holding cost is different because the holding cost is a percent of the price you pay. So if it's 10%, it'd be 10% of full price. If it's if the holding cost is 10%, again, it's always 10%, whatever it is, times different prices though. Full price, then take the 10% times the discount price, then take the 10% times the next discount. So you have a different CH for every total cost, you have a different cost for every cost, and you're gonna use a different quantity for each cost also, because there's a certain amount you gotta order. Here's where the EOQ comes in. You ready? This is a film company. They order film, they sell a whole bunch of camera stuff. We're just looking at this one brand of film, back in the old days when they had film, from the supplier, okay? We're looking at this one. We realize we're going through 21 rolls a week of this film that we're buying from the supplier, this one item. What's demand? What do I gotta do to find demand? Let me ask you that.
1 week times by 52.
You're gonna have to take 21 rolls times however many weeks they're open, and if it doesn't tell you, you gotta assume a whole year, which would be 52 to get that annual demand. 21 rolls a week. The holding cost is 25% of the cost of the film, 25% times full price, 25% times the first discount, 25% times the price of the second, and so on. So that's what's gonna change. Every time we place an order, $20. Doesn't matter how many we're ordering. To put together the order in places, we're eating up $20 a time. All right, there we go. Here's what the supplier said. The supplier said, we're gonna give you a full price. You pay full price if you order between $1 and $399. If you increase your order to $400, we're gonna give you a 7% discount off full price. And you can get that discount all the way to $899. If you increase your order to at least $900 or more, we'll give you a 10% discount, all the way up to $1,999. And if you increase your order all the way to $2,000, we're going to give you a big 15% discount. Why not buy for the whole year? Get the big discount, right? Now, if you're working at a grocery supplier or grocery stores, this is a big deal at grocery stores, because any product that your company makes or buys that has that could perish in time, it's called a perishable. Like milk, it can only last so many days, and you got to either throw it out, give it back to the supplier, you can't sell it. If a perishable is involved, this is a big deal. The hugest mistake a new manager can make is order too many to where you have to throw some out because it went past its date before you can sell them. That's the hugest mistake. The amount of money it takes to throw one out will eat up any money saved by increasing your order. And it ends up having the opposite effect of what you really wanted to have. So it's a huge mistake, perishable. In this example, the film happens to be a perishable. And the film only can last, unfortunately the film's shelf life is 18 months. So if we order too many, and that film has to sit there for longer than 18 months, we have to throw it out. And we're selling how many on average? Okay. On average, we're selling 21 rolls. Let me see. This is 21 per week. How many weeks in 18 months? How many? 78. 78. 4 weeks a month times, 21 times 4 will give you the month. Then times 18. So 21. Then what was 21 times 4 times 18 months is 70, say it again, 78? 78 rolls is how many we could go through on average in 18 months. So if we order more than 78 rolls, is that right?
No.
No. What is this?
That's 78.
78 weeks. Okay, 21 times, 4 times 18 is 78 times 21. 21 rolls equals, here we go, 1,638. Thank you. If we order more than 1,638 rolls probability is much greater, is greater than 50% that we're gonna be throwing some out. And you wanna play the odds. You don't wanna throw any out. That should be your ultimate goal. Because losing the margin you make on it, that's not a big deal. Hey, I bought it too low, and now I gotta reduce the price, and you're gonna reduce your margin. Throwing something out, you're not just losing the margin, you're losing the cost of the individual item, which will eat up, 10 other margins from the other products. So you can't get to that point. Sure enough, the biggest discount, you have to order at least 2,000. We will never, ever be able to take advantage of the biggest discount. It is over our average amount of rolls we go through in 18 months. So the 15% discount is out of the picture. You just put a sentence, if this were the case, you put a sentence that says, we'll never order 2,000 rolls because it's a perishable, and we would on average only go through 1,638. Now we have 3 price points. Full price, 7% discount, and 10% discount. We're either ordering between 1 and 400, or $3.99, 400 to $8.99, or 900 to 1,999. And we'll never order more than 1,680 or whatever that calculated up to, 1,638. So, but we still can be ordered in all 3 price points. Now, this should make sense. You calculate the optimal quantity for each price point. You ready? I'm going to go to, let's go to this one. 10% off. So you're paying 90% of that price. 10% off means you pay 90% of the full price, which is $2.88. So $2.88 times 25% your holding cost, $20 to place an order. We go through 1,092 a year, this 2. Do all the work, square root it. The optimal quantity to order at 10% off is 246 rolls. The supplier says, wait a minute. I'm not going to give you 10% off if you order 246 because to get 10% off, we have to order at least 900 rolls. So that's why the optimal quantity is not feasible. And when we calculate total cost, we're not going to use 200 and whatever we just calculated. We're going to order the minimum to take advantage of it if we want this price. So we're going to order 900 because there is no optimal quantity between 900 and 1,099. There is no optimal quantity. And if we want that discount, why order more than the minimum? We're ordering 900. And so when we go to total cost, which is where all this is heading, we got to use 900, the minimum, because the optimal quantity did not make sense. All right, let's go to a 7% discount. We're going to pay 93% of full price, which takes our price down to $2.97.5. Multiply that times the 25% to get our holding cost. This is still the same, this is still the same, still the same. Square root, slightly different, 242.3. If we want 7% off, it says we should be ordering 242.3, but if we want 7% off, we can't order 242.3. In fact, it says to get 7% off, we have to order at least 400. So when we figure out total cost for this price point, we're ordering the minimum because the optimal quantity is not between 400 and 899. So when we calculate it, we're ordering the minimum, 400.
So if they did give you an optimal quantity, say it was like 500 and something, then would you put that 500 in?
That's right. Because we would never order, if that optimal quantity fits in that discount range, that's the exact number we would order if we're taking that discount. Okay? So in this case, it doesn't fit. We're going to order the minimum. We figured out total cost using 400 for this one. Because the optimal quantity didn't make sense. We'll order the minimum. Now there's, where's the other? Now there's full price. We have to order at least 1 to get full price. 2 times the annual, everything's the same, 25% of full price now instead. Square root it, 233.67. To pay full price, we would have to order between 1 and 399. Since the optimal quantity fits between the range at full price, that's how many we would order if we do make the decision to pay full price. Exactly 234 rolls. So we're going to calculate total cost based on that quantity. We would never order 1 We would never order 3. We would never order 399. We would order the optimal quantity since it makes sense and fits in the range. We have, so now, for all 3 price points that are available for us, because the biggest discount's not available because it's perishable, we calculate total cost and decide how many to order. Here's the changes. The quantity, because we calculated where the optimal quantity would fit and what would be the minimum amount to order for these. The holding cost, because 25% of 288, 25% of 297.5 cents, 25% of full price, so that changes. Same. Quantities again, optimal quantity, minimum order, because optimal didn't fit. Here's the new part that you haven't seen before. How many we go through in a year is the same, but here's the 3 different prices we would pay if we took discounts. Full price, 7%, 10%. Do all the math on this, look at the 3 numbers. Should we be ordering 234, 400, or 900? Which one gives us our lowest total cost? The 400, 3,453. We only save $40 a year compared to ordering 900. But why order 900 when it's telling us to order 400? Let's stay with the optimal. And if we go full price, look, we are losing over 200 a year going that direction. So take even, you got the management position and you said, okay, at least I'm smart enough not to order the 15% off because that's more than we go through. But I'm telling you, when you're a new manager, your temptation is to buy 900, when in the big picture, you would have saved money ordering 400 compared to 900. Here's my favorite slide. All right, how we doing? You doing okay? Get 5 minutes to talk about the homework. I want to talk about the other 2 problems. There's 3 problems on the homework I do. Is it due tomorrow?
No,
This time I do. All right, the first question says, an office supply, I'm posting this as soon as I get home. All right, it'll be posted. I just got to grab something to eat out of here. The office supply store is open 6 days a week, 50 weeks a year. This one's given to you, and this is not a full year, so take that into consideration. What's it say? An office supply store, which is open 6 days a year, 12 years, must determine the best inventory policy for boxes of copier paper. Weekly demand is nearly 132 boxes. Weekly demand, let me point that out. I'm just making sure everybody realizes this. It says weekly demand. 132 boxes. The cost per box is $20, and your holding cost is 10%. 10% of something, right? 10% of times something. I'm just making sure. Orders are placed at a cost of $62 per order, and prep time for the prep time communications, and the lead time is 4 days. Where's the question?
Oh, cool. Got an equation. What do we do?
How did I erase the question? I was in a hurry, put this together. Darn it. I'll fix this before I post it. But the question's going to say, calculate the optimal quantity that you have to order from your supplier, calculate the reorder point, and calculate the total cost. That's what's going to be the question on that one. I somehow got erased. The second one we talked about already, but I didn't tell you what. You got the recommended production lot size on this one, total cost, and how many setups, how many runs per year. Those are the 3 equations on that one. Right? The exact 3 areas on each of those I told you to be prepared to study. The last homework problem is the back order problem, which we talked about a little bit. The manager is, oh, you know what? We didn't talk about, I thought it was the second one we talked about already. Let me read this one. Kellum Images prints snack food bags on a long roll of plastic film. The plant operates 280 days a year, not 365, 280. Daily production rates 3,000, not times 365 days. Daily production rates 3,000 bags, only times the number of days they're open, okay? I mean, there's a big hint there. Demand is 1,800 bags, daily demand. It's got to be annual, it's got to be annual. The cost is for setting up the design is $275. There's your setup cost. Holding cost is 1.5 cents. Uh-oh. This is the first time it hasn't been given to you as a percentage. So I give you a big hint here. turn it into dollars, because everything else is in dollars. All right, 1.5 cents looks like this for your holding cost. You don't have to multiply it times anything. It's not given to you as a percentage. It's given to you as an amount. It's asking for the recommended production lot size, total cost, how many setups a year. And then the last one, back order, you have 1 more minute. You're managing the inventory system. They're thinking about a back order policy. We already talked about this. Demand is already given to you per year. Setup or ordering cost. Look at this, holding cost $3. Here's their second one you've ever seen where the holding cost is an amount instead of percentage, so you don't need to calculate it. Back order cost $25. It's saying what's the difference in total annual cost doing an EOQ where you wouldn't use back order and then doing a total cost with a back order. You gotta do this one twice. This homework is gonna take you about an hour. And again, well, it's fresh in your mind, you may consider attacking this a little bit tonight. Maybe at least getting it all set up. Well, it's fresh in your mind. All right, I'll see you in 2 days.